Theory and Practice of Silviculture, lecture number 1. This is a series of lectures on silviculture. So we'll start with silviculture as the theory and practice of silviculture. So let's understand about first what is forest and what is forestry, because to start a silviculture we need to study about and know about forest. What do you mean by forest, and what do you mean by forestry? Anyway, let's understand what is forest. The word forest is derived from the Latin word called foris. Now what is forest? Forest means outside. Latin word forest means outside. Now a plant association predominantly of trees and woody vegetation occupying an extensive area of land. Now what is extensive area of land? This is the entire, you can see, extensive area of land. And as I told, forest means outside. So let's see, this is a village, a habitation here, and the forest is outside the habitation of the boundary. So an area set aside for the production of timber or maintained under woody vegetation. Now this all is, we can say, woody vegetation. What I want to say is the area which is outside the boundary of habitation, we can say it is a forest. But legally an area is proclaimed to be a forest under a forest law. What does it mean that an area proclaimed to be a forest under forest law? Legal definition is whether this area, let's assume this area, there is no trees, but legally this is defined as a forest land. So we say that, and this is also forest, but under forest law. Now definition wise, let's come to a definition which actually tell what is a forest. Now I say here, a plant community predominantly of trees and other woody vegetation, usually with a close canopy. Now a close canopy means you have a trees, and those trees which have a crown, and those crown are now together, and we see here it is a close canopy. So it is a plant community predominantly of trees. Now what I said, trees, now you can see these all are trees here, these all are trees here. So these trees under a close canopy. So we can see here that this is the entire forest set aside for production of timber or maintained under woody vegetations. So also we can say a plant community predominantly of trees and other woody vegetation, usually with a close canopy. This is called forest. What is forestry? Forestry, let's see the definition. What does forestry says? Forestry says two things. One, it says theory, one it says practices. Now theory means we have to understand the entire knowledge about the entire trees, forest, and its practice, practically how to do that one. So forestry is a theory and practice of all that constitute what? Number 1, creation. Number 2, conservation. Number 3, scientific management. And number 4 is utilization. Now let's read the definition. Forestry is the theory and practice of all that constitutes. What it constitutes? Number 1, creation, conservation, scientific management of forest, and the utilization. Now we have to first create, then we have to conserve, then we have to manage it, and then we have to utilize it for the resources. Because for resources, what it is been utilized, it should be continuous production for the goods and services. So that is forestry. In forestry we have to create, we have to conserve, we have to manage, and then we have to utilize it. That is called forestry. Now forestry we have to do, but without silvics and silviculture it is not possible. Now we have to understand silvics to do silviculture. Now what I say is silviculture. Silviculture. What is silviculture? Let's have a very simple meaning. Silvi is a German word called silvi means trees, and culture means to grow, to create. Now silviculture, growing trees. Okay. Before that, to do silviculture, we need to understand silvics. Without silvics, we cannot do silviculture. Now, what is silvics? Now, let's understand about what is silvics. When we see the definitions here, this is a definition here telling about silvics. The study of life history and general characteristics of forestry. Now, what I say life history. Life history and general characteristics of a tree, but particularly with reference to the environmental factors. Now, what do it says here? It explains the natural law of their growth. What is natural law of their growth? Natural law of their growth. See, the growth and development is affected by the environment, and how it grows, naturally how it grows with the environment, means how the trees they behave with a given set of environmental conditions. For example, if you see this tree is a very tall tree, and this tree, how it is coming up with these weather conditions, like we can say climatic condition, edaphic conditions, or we have to understand that this tree is coming in this environment, within this particular environment with good warmth or good temperature, with good rainfall. It is acting very nicely, it is growing with good height, good volume it is giving, it likes this environment, so it behaves very nicely in this environment. But nearby this tree is very small one, means it doesn't like that much environment which this A tree likes. Suppose let's take this is A tree and this is B tree. A tree likes this environment very nice, its behavior in this given set of condition is very suitable, but this is not very suitable, B tree. So it means that this tree, we have to know that life history of this tree, that it acts very well, very nice growth and development under the particular set of condition, but this B tree is not coming nicely. So we can understand now the life history of the tree. By knowing this life history of a tree, we can grow the trees in the particular set of environmental condition. So silvics is very important to understand the life history and the general characteristics of a tree with that environment. So if we know the silvics of a tree, its liking, its disliking, then only we can go for silviculture. Now let's understand silviculture. So as I told you, silvi word is tree and culture word is to grow it. So we say silviculture is the art and science of growing or cultivating forest crop. Silviculture is an art and science of growing forest crops. But ultimate, to do silviculture, we have to know about the habitat factor, site factor, or locality factor. Means if we don't know the environmental condition of that area, we are not able to do the silviculture nicely. So we should know the silvics, under which environmental condition the tree grows very nicely. So we say that growing of a forest crop is mainly governed by many factors operating in that area or in that locality. Either I say the word locality, either I say the word habitat, or I say the word site. Okay. So we have to understand that the forest crop which is governing by those factors. What are those factors? You see that there may be climatic factors in that area, how the rainfall is there, how much temperature is there, maybe the edaphic factor in that area, what is the soil conditions there, maybe the topographic factor, what is the terrains there, and maybe the biotic factor, what is the biotic factor giving a pressure. All these factors we have to understand, that what are the trees likings and dislikings in that area. Then only we can go for silviculture. Silviculture, you see how creation, we have to create in forestry. What we have to do first is creation. So after it comes up seedling sapling, now we have to do conservation. In forestry, then we do conservation from biotic influences by your insect, pest, fire. Then after that we have to go for management by thinning it. If it is too much close, then we reduce those competition and let them grow freely by cutting few of the trees, called thinning. And then tree grows in a very good volume. You can see it growing in a very good volume. And now after that scientific management, what we are doing? We are doing utilization. So we know what is forest. Now what is forestry? Creation, conservation, scientific management and utilization. Then to do all these things, we have to understand Silvics. Silvics is what? Silvics is the life history or general characteristics of the tree to the particular environment. Okay, then after knowing that one, we can do silviculture now. Silviculture is a theory and practice of growing the trees. But to do the silviculture, we have to know the locality factor, site factor or habitat factor. What are those factors? We'll study in this lecture now. Let's come to the locality factor, because knowing the locality factor only, we can go for silviculture. That is very important. Now, environment includes what? Abiotic as well as biotic components. There are two components in environment, and this environment, either directly, indirectly, they affect the plants process in their growth, in their development, in their germinations. So what is locality factor? What I want to tell you, locality factor, or you can say site factor, or you can say habitat factor. Let's know that, go for the definition. Now, factors of the locality is defined as either factor for locality or a site factor or habitat factor, same thing. It says that effective climatic, topographic, edaphic and biotic conditions operating in that area or a site which have influence on the biotic component. I say biotic component, either is a forest or the trees of that area. So definition says that effective climatic, number 1, topographic, number 2, edaphic, number 3 and biotic, number 4. These 4 factors operating in that area influencing what? The forest or trees of that area is called locality factor. Let's understand very nicely. So your trees, your forest, this is your forest, this is your forest. So these all forests means, number 1, factor of locality is what? Number 1 is climatic. So let's see what is the climatic like. This climatic having influence on the forest. Then topographic, up and down terrains of the hills and mountains, influence on your forest. Then edaphic characteristics, what is the soil characteristics influencing on the forest, and then what is the biotic factor influencing on the forest. These 4 factors. Factor of locality is classified into 4 categories. Number 1, climatic, physiographic or topographic, biotic, edaphic. These all factors, how they are affecting the trees, how they are affecting the forest, how they influence the forest to grow. These 4 factors is called locality factors. Knowing these locality factors, we can go for silviculture. Now, number 1 factor, just now I told you, it is climatic factor. So this climatic factor, what are these climatic factor? May have solar radiations like light and heat and temperature, may have moisture, may have wind, so and so. This is called climatic factor affecting your forest. Number 2 is called topographic factor. You can see the configuration of land, up and down, up and down. Then we have altitude. Altitude, you understand? From the mean sea level, how much more height it goes, the mountains. Then latitude, from the equator, how much it goes to the north or south. Then the slope of the mountains, aspect and exposures to the weather condition where the mountain faces. So this is topographical factor. How much this topographical factor affect your trees, affect your forest. Then third one is edaphic factor. Edaphic factor is related to soil, your physical property of the soil, chemical property of the soil, how much they affect your vegetation or your forest. And the last one is called biotic factors, means how much your trees plants affecting the plants, wild animals have an effect on the trees, regeneration or growth, then insect pest have influencing your forest, then man itself is domestic animal itself, how much they are affecting your forest. These are the 4 factors we'll be studying in these lectures. So number 1 we'll study with, first is called climatic factors. Now under climatic factors, let's go for the definition. What climate? A climate is an average weather condition, prevailing in an area, whereas weather is classified as temperature, humidity and pressure condition at a particular time. Weather is characterized by temperature, humidity, pressure of an area at a particular time. So climate is defined as average weather conditions. Now what are there in the climate? Let's classify the climate. We have number 1, solar radiation in the climate. What is solar radiation? Will include 2 things. Sun gives 2 things. One is light, heat and temperature. Number 2 is moisture. Moisture will have your clouds, moisture will have your rainfall, moisture will have your humidity, dew, frost, snow or a form of precipitations. Then we have a last called wind. Okay, so these climatic factors, let's understand the climatic factor, how it influences, how it affects the vegetation. We are going to study the locality factor, where we have classified into 4 categories, and number 1 is climate we'll study. Under the climate, number 1 we'll study now solar radiation. Under solar radiation we'll study about the light and heat and temperature. So the climate of a locality has a comparative great influence upon germination, growth, development of your trees, forest. So we are going to study the first. By the sun we have what? Solar radiation. We get light, we get temperature, we get light, we get temperature. Temperature may be more or temperature will go down to freezing. So let's understand first about the light and temperature. Then we'll study about the moisture. Moisture is by your rainfall, your snow, your dew, your frost. Then we'll study about the wind. But this lecture we're going to study about the first, solar radiation affecting your forest, affecting your trees, under which first is light, then temperature. Let's study the first called light. How the light affects your trees on the growth and development. And light, how it comes? It comes from the solar radiation. This is your sun. From your sun you have energy radiated by the sun in the form of what? Electromagnetic wavelength. Now what is electromagnetic? There is a lot of electromagnetic wavelength coming from 290 millimicrons to 5300 millimicrons. Okay, and when it reaches the earth, your earth, around 32 to 40% it is reflected back, called albedo. We call it albedo. Okay, so rest we receive in the earth. Now when we receive in the earth, this visible, see what we receive, visible wavelength is, we receive 39%, and that is from 400 to 720 millimicrons. Then we receive ultraviolet only 1%, and that is less than 400 millimicrons. And then we have infrared, which is 60%, and it is above 720 millimicrons, and that is 60%, but the visible is 39%. Now in that one, first light, number 1, light is what? It is needed for the formation of chlorophyll, because trees, they have green foliage and chlorophyll is very important, and light is needed for the formation of chlorophyll, because the amount of chlorophyll, what does chlorophyll do? Chlorophyll affects the quality and quantity of photosynthesis. Now everybody know what is photosynthesis. In photosynthesis, what it happen? If you have a good photosynthesis, we'll have a very good growth, we'll have a very good photosynthate. Photosynthate will convert into sugars, which will convert into cellulose, and that cellulose is a wood. But if we don't have a good light, what happens? The leaves turn to yellow, called etiolation, because we don't have a very good formation of chlorophyll. So photosynthesis is an oxidation reduction process in which the energy rich carbon containing compounds are produced from carbon dioxide and water, all this you have studied in your intermediate classes. With the help of light it forms sugar. Now this sugar, it forms water and give oxygen to us. That is very important nowadays. Oxygen is very important, where trees give enormous of oxygen. But here this sugars which is converted into cellulose, and this cellulose is wood. Okay, so that's why light is very important, because it ultimately gives the formation of the wood. And among that, red and blue colors of the visible part of the spectrum is effective in photosynthesis. Then light also influences what? It influences very important physiological activity, that is called opening and closing of stomata. This is a stomata, you see, this is a stomata. We have chloroplast, this is a guard cell. So opening and closing of stomata, here you can see the stomata is open, so this is closed. So opening and closing of a stomata. In the leaves we have chlorophyll, see we have this chlorophyll, and here we have stomata. So this daily opening and closing of stomata is been influenced. What it influences? It influences, number one, transpiration. See, that is a very important physiological activity. Then it also, because this also goes for absorption and release of carbon dioxide, oxygen, thereby controls respiration and photosynthesis also. So that's why light is a very important for opening and closing of stomata for the physiological process. Then light is also very important for the growth. Now what do I mean to say growth? Now generally in a forest, light is required 1 to 1.5% of the full sunlight. The best growth takes place in moderate light. Food is available, nor we need very high intense light, nor we need very less light. Moderate light, the forest grows very nicely. But lack of the light, if the light is very less, what will happen? You can see the trees which are light demanding will go in a VP shape. Okay, it is very VP shape, very VP, very feeble. You'll have a stress. It gives a stress, because this is a light demanding. It want to come in the top of the canopy, but due to unavailability of light, it will in coming 1-2 years it will die. It will try to struggle and it will die if you are not able to provide light in the lower canopy. But there are some trees which are, it comes under the shade. They are a shade demander, or you can say shade bearer trees. They may be shade demander or shade bearer. Okay, shade demander or shade bearer. These are called tolerant, Tolerant. These are called tolerant trees. Tolerant what? It tolerates the shade. So it has a habit. The silvics we study, it likes shade. So they have no problem. They will have a big leaves. They will modify their leaves. They will stay under the shade and they will stay in the lower canopy. So they don't have much problem. But the problem is light demanding. If there are some which are on the edge, they will try to bend outside. If it is in the edge of the, it try to bend outside. You can see it is bending outside to have light. So you can see the growth. So optimum light, you have a good growth. See those which are in the top canopy, they grow very nicely. The good growth, they are having a light is sufficient for the photosynthesis to make the food. Then light also makes the one more thing, form and quality of the trees. What do you mean by form? Form is shape. When I say form of a tree, I mean to say shape. So this form factor, some lectures are there of forest mensuration. You can go in detail on that forest mensuration. But here form, I'll say, is a shape of a tree. Shape of a tree may be a very cylindrical shape, or shape may be a very, you can see this is how tapered shape, like a triangle, the tapered shape. So it affects, light affects the shape. How it affects the shape and how it affects the quality, let's understand. If you have a trees which are very closed, which are planted very close, they are going for competitions. During this competition, they will grow above, they will go to the sky. In going to the sky, they will compete for the light. When they go, they will come at some level. At that level, now what happens? You will have this type of cylindrical type of bowl. Cylindrical. cylindrical type of bowl. But during this, because they are fighting for the light, they are light demander species. As they go up, the lower canopy, the lower side branches, because they will not get much light, what will happen? These branches, lower branches will die and they will fall down. So we'll have clear bowl. Light helps to rush to the sky, under which it will become a cylindrical shape. So a form will be better. Later you can remove few trees and remove the competition, they'll get space to grow. But first we need to go to the sky, and so that it becomes a cylindrical shape. But when it is in the open, there is no competition, light is from all the side. So what it will happen, it will tend to become taperness. So to study about the detail of this one, you can go to the lectures on forest mensuration lectures already available. That is, you can study the form factor. Now this is how the light, because the forester get this very powerful tool to manage the tree, to give a good form, a good cylindrical tree with clear bowl with the help of light. So the regulation of a light gives the forester a powerful weapon to regulate the form and the quality of a timber in the forest. Now we have to know about the light increment. What do you mean by light increment? This light increment, or another word we call it increment felling. Increment felling. Now what do you mean by light? Light is, we have just told you, the sunlight only. Increment is to increase how the tree has developed, how the trees become a bit fat. It's called increment. Now let's see how the light helps in increment felling. Now light results in the formation of relative large crown, because light helps to give a large crown to develop for more photosynthesis and rapid growth. Now advantage is taken in this fact. Now what we do towards the end of rotation, when we know, suppose a tree we cut down at 15 years, but towards the end of 15 years or end of rotation, like we go to 8th year, 9th year or 10th year, during that time we do some thinning, or we open up the crowns, so that competition is bit reduced and the tree gets more light and it develops more. Now we have to understand how the light stimulates its growth. How the light stimulates its growth, let's understand by this. So this is a forest. Let's see, this is around 15 years it matures. And around 8 to 9 years, what we do when it reaches 8 to 9 years, there are lot of trees are there, like 7 trees we see here. We are having 7 trees here, and we have reduced it to 4 in numbers. Let's see, there are 7 trees competing with each another. We are keeping it intentionally. First, what to do to improve its form, so that they will fight for the height growth first. Then it will have a clear bowl. And after, to the end of rotation, let's take an example, by 8th to 9th year, what we will do, we will cut down few of the trees to give them space, and these trees we can use in other, like pulp and paper and some other uses. Then what we do, these trees we have cut down here. Now they get enough space. See, they are getting a growing space. This growing space, they are using the light now. This crown are using the light to grow. More photosynthesis is happening. More photosynthesis is coming. It will grow in a good speed. So this will stimulate to grow. And see, now it has grown in a good height. Good, by 15 years we get a very good bowl, cylindrical bowl, quality one. And then this is called, this growth, this increment is called light increment. Now light does one more thing, that is called, it affects the size and structure of the leaf. How the light affects the size, structure and color of the leaf, means the leaves which are open, which are exposed, these are light demanding trees. Always the leaves will be a bit smaller in size, to tendency that there enough light they are getting so they can do photosynthesis. But the trees which are on the lower canopy, they tend to become bigger size in leaf, because the sunlight have now what? It is exposed to sunlight, rich amount of palisade tissue in comparison of interior. Here we have more palisade tissues, but interior crown which remains under shade. Now that is what I want to tell you, that the leaves exposed to full are smaller in part than as compared to partial light. So the leaves located in upper crown are fully exposed in sunlight, having rich amount of pellucid tissues in comparison to the interior crown. So it affects the size, it affects the color and the structure of the leaves with the light. Now light does two more things. Now either it is extremely high light, this is extremely high light, or extremely very low. Either high, either low extreme, both are very bad. Now let's see, if you have extremely high light when the trees are in the let's assume in the top of the hill where we get more light intensity, what happens to the trees? It affects the root growth. So root growth will be more, because it favors the root growth with the high light intensity, but it affects the stem growth. Stem will be shortened, dwarfed. Then shortening and thickening of leaves will be there. Increase in alkalinity in the sap will be there. Breakdown of chlorophyll resulting in chlorosis will be there with a high light intensity. I say extremely high light intensity. That's why we need a moderate light intensity. Let's go to the extremely low light intensity. In extremely low light intensity, there is what formation of, or we can say limiting the formation and development of the leaves will be less. Then reduction in the growth will be there. Weakening of stem and the leaves will be there. Decreasing flowering and the fruiting will be there. So low fruiting, low flowering will be there. So both light, either high, either low, both are not good. Light also gives one word called stratification. Now what do I mean by stratification? You see stratification, you can see this forest. This is the emergent layer. You can see this emergent layer. Then this is the second one where we can say co-dominant. These are co-dominant. Then we have some intermediate. These are some intermediate crowns here. Then we have some, this lower one we call it shade bearer. And the last one we call it shade demander. See, we have 1, 2, 3, 4, 5 strata. 1 strata, 2 strata, 3 strata, 4 strata and 5 strata. This is called stratification. It's just because of the light. So full light reaches the top canopy and the lower canopy is received only very less light. This results stratification. Now the light reaching the forest floor is considerably less. The difference in light arrangement resulting in the stratification in the different canopies. Now species adjust themselves. Those species who want light will come in the top, who want bit moderate light will come on bit the co-dominant, which species want bit more less light will come on the lower, which doesn't want much light they will go on the lower. They adjust themselves. The trees make themselves their places in the respective strata. We can see here, we called it a light demander species which are dominant on the top. This is light demander species. Then which are moderate light demander species, we call it co-dominant. This one we call it co-dominant, which will come bit below that top canopy layer. Then that is intermediate. We can see it is coming more below this one, bit less light it needs. Then we have some suppressed trees where are shade bearer, this one, and shade demander. So there's a difference. Shade bearer will be bit light it needs, but it doesn't, it can stay there. But light, shade demander, they don't need much light. They can survive under that bit less light also. We call it tolerant species. So these are called tolerant species. These all are called tolerant species. And these are called, upper one is called intolerant species. Intolerant. Because they don't tolerate shade. That is why intolerant species or light demanding species. So there are some examples. We see tropical wet evergreen forest in forest type of India. Already people have studied. If not studied, there are a lot of literature available for forest type of India. There are 16 forest type of Indian country. So under that one, where tropical wet evergreen forest are there, light demander species. Just an example I'm giving you: Dipterocarpus species, then shade bearer Artocarpus, then shade demander Mesoaphera. Okay, this is under tropical wet evergreen. Tropical means temperature is there, tropical temperature, wet means lot of rainfall, and evergreen trees means there is very less deciduous species. Then tropical moist deciduous species. An example for tropical moist deciduous species, light demander on the top canopy are Shorea robusta, Tectona grandis, then shade bearer are Tuna ciliata and Dalbergia latifolia, and shade demander is Melatus philippinis and Syzygium cumini. Let's come to moist temperate forest. In moist temperate forest, we have light demander, Pinus vallicina, Populus silata, shade bearer, Citrus deodara, and Quercus dilatata. Then shade demanders, Abies pindo, and Taxus baccata. So there are some species, more number of species are there available in the literatures. For examination point of view, this to know about the species is important. Which species are in which forest type and what are on the light demander, shade bearer, and shade demander. Just I explained you. Now we'll understand about the photoperiod, that is also effect of light. What is photoperiod? Now just a simple photoperiod, we have to understand what is photoperiod. So photoperiodism is a phenomena of a physiological change that occur in plant in response to relative length of the day. Relative length of the day is called photoperiod. Now photoperiod varies with altitude and latitude. With altitude and latitude, this is if you have a mountain here, if you go from mean sea level to top, is called altitude, and if this is your globe, this is your equator. When we go to the north and when we go to south, going up is called latitude, or here we call latitude. Okay, up and down. So with this latitude going from equator to the north or south is called latitude or altitude. This photoperiod is affected because photoperiod is what? Response or relative length of the day. So there are a lot of species which has been affected by photoperiod. You can see the day length period is 6 to 8 hours. We call it short day plants. When it is 14 to 16 hours of day length, we call it long day plants. So some require very less light, called 8 to 10 hours, we call it short day plants, and some require long one. So in our country, if you see, this is short day plants which will be favorable here when we go to the from our this central India to the northern side. Okay, because and when we go to the southern side, it is called long day plants. Okay, it is 14 to 16 hours. Now, but this photoperiod affects for those trees which are short day plants, because it affects its growth. It also for breaking the dormancy of the tree. It affects the germination. It affects the leaf fall and flowering. So there are a lot of effect on the those trees which are photoperiodic sensitive trees. So photoperiod at higher latitude is less. Always remember in exams it comes that photoperiod at higher latitude means here we go more higher latitude, it is less. This photoperiod is very less. Okay, because this photoperiod physiological changes occurs in the response to relative length and day. Now one example I want to give under the family called Salicaceae, and one of the species called poplar, very much been planted in this entire part. You can go Jammu, Himachal, Punjab, Haryana, in some western part of Uttar Pradesh, because it has been highly photoperiodic sensitive tree called poplar. Okay, they act very nice under 28° north latitude. Above 20°8 north latitude, they grow very nicely. Their development is very good. Their germination is good, and their flowering is good. Everything is well. But as you want to plant this species on the lower latitude, the growth ceases. It doesn't come. This is one picture showing this Populus deltoides, or called poplar. A very highly commercial tree for plywood and for paper, which has been planted in agroforestry. So this is highly photoperiodic sensitive tree. So similar, there are a lot of trees which are photoperiodic sensitive trees, and that's why light has been affected by that one. Now we come to number 2 after light is called heat and temperature, either high temperature, either low temperature. Let's see what is the effect on that one. Heat and temperature. Heat is what we do in joules, is the energy between the two systems. Okay, and then what is temperature? We do in Celsius or we go in Kelvin. Okay, degree centigrade. So let's understand about the heat and temperature, how it affects. Now this is also been modified. Now when we see latitude, if it is in the equator, here the heat or temperature will be more here. But as we go, if your trees and forests are here, now the sun is a very oblique, sun is here, the temperature will decrease. The temperature will decrease as the increase in your latitude. But temperature also decreases on the altitude also. When we see altitude from this is a mountain, when we go in the up here like this, so temperature also decreases as we go up in the hills and up in the mountain. Now, So this temperature is been modified with the latitude, with the altitude. So it has been observed that there is a fall of 1 degree centigrade in mean temperature in the hills for every 270 meter rise in altitude. As we try to go up in the mountain from here, every 270 meter, as we climb, 1 degree centigrade fall in temperature will be there up to 1500 mean sea level. But after 1500 mean sea level, if you want to go more height, what will happen? Then our temperature fall will be more rapid than 1 degree centigrade. It will go more down. Okay, so that is what the altitude and latitude has effect on the temperature. Okay. Now, not only that altitude, latitude, distance from the sea. If this is a sea and your forests are here, so what will happen? There is a diurnal and a seasonal changes of temperature. Not only that, wind which is coming from the sea also affect the change in temperature. So that is also, so temperature has a modification with the latitude, with the altitude, with the distance from the sea and from the wind. And from the mountains also, so range of mountains. You can see in the Himalayas, these are all on the northern side. So in the northern side we have a range of the mountains. They also affect the temperature because you can see the wind is coming from here. Also, if you see the mountain is here, if you the wind is striking in this side, your temperature will be very different because your rains are coming here, the temperature. So temperature will be more on the southern side, southern aspect of your mountains, this side, southern side, which is striking here. On the back side, which is called northern side, will be bit less. Okay. So it's also affect with the slope also. More the slope, more the temperature, because it will strike at that oblique angle. Okay. Then temperature also modify the cloudiness. If there is a cloud more, the temperature will be less in that area. Also with the presence and absence of the forest vegetation. Because on the open area, you can see in the open area, temperature will be more. And when there is a lot of vegetation there, the temperature will be less. So presence and absence of forest vegetation is also been affected, modified. Your temperature has been modified there. So let's understand the kind and their importance. What is the importance and the different kind of temperature? Two kind of temperatures: air temperature or soil temperature. Let's see the importance of air temperature. So higher the temperature, what will happen in the forest? It will increase the transpiration. So increase in temperature do one more thing. Up to 25 degrees centigrade, it increases the photosynthesis. After that it decreases. So your photosynthesis is affected. Photosynthesis means your wood is being affected. Production of wood is being affected. Rate of respiration increases up to 40 degrees centigrade. But after that it decreases sharply. Okay. Increase in microbial activity on the soil surfaces. That is very important with the temperature, because this microbial activity, it does decomposition of organic matter, and this organic matter decomposition will release the nutrients which will be available to trees, and then the trees will grow, the wood will be more, volume will be more. Then the temperature also affect the enzymes, and practically stops at 50 degrees centigrade or below 1 degree centigrade. So enzyme activity is very important because it affects the growth. It also increases the cambial activity, and that is very important for the shoot portion and the increment and the growth of the tree. Now temperature also affects the germination. So germination with the seeds, because regeneration is very important. So 20 to 35 degrees centigrade, it comes very nicely. Let's revise it very fastly. So what does temperature do? Temperature increase the transpiration in water. More water will be there, more heat, more transpiration, more loss of water. As I told you, photosynthesis is very important, and then temperature affect the photosynthesis, 25 degrees centigrade. After that, just now I told you that increase in temperature to 25 degrees centigrade, increase in photosynthesis, this one. Then respiration is very, very important, because respiration is very important. What does in respiration it does? Rate of respiration up to 40 degrees centigrade. After that it decreases very sharply. Microbial activity is very important, because ultimate it helps in decomposition, like bacteria, fungi, everything is there, and this decomposition will help the nutrients to uptake Okay, that's important. Then temperature, as I told you, enzyme activity. Everybody know enzyme activity. We have studied what is enzyme. In enzyme, what happens? This is the active site. We have substrate. This is a bond. This substrate, this bond will come here, and then they will give the products. Okay, this enzymic activity for the growth, ultimately growth and development of the trees. So this enzyme activity is being stopped with high or very low temperature, and that is very, very important for the forest, and to understand how the temperature is very important. Okay, then ultimate regeneration is dependent on the future growth of the forest, and that is by germination, which is very good in 20 to 30 degrees centigrade. Now we come to the soil temperature. Soil temperature which is important in many exams to come, that what is the best absorption of the soil moisture for the trees is very good when the temperature is between 27 to 35 degrees centigrade. Okay, but it affects the cambial activity also. So in temperate climate very less cambial activity happens, so that is very important. If it is warm soil, it comes very high. So higher soil temperature is indicative, more better temperature, more better growth of the trees will be there. So that is what how the temperature limits the particular species, where it should come, where it should not come. Now this temperature has made the classification under 4 zones. Now what are those 4 zones? We have to understand the temperature has divided into 4 zones. One is called tropical, all know tropical forest. So tropical is over 24 degrees centigrade. When we have the mean annual temperature to about 24 degrees centigrade, we call it tropical. Then it is divided for subtropical, 17 to 24 degrees centigrade. Then temperate is 7 to 17 degrees centigrade. And then we have alpine, that is alpine zone in the here in the Leh, Ladakh, and higher places called under 7 degrees centigrade. So it classifies the vegetation broadly into 4. So let's see under 4, as I told you, tropical, where we have the mean annual temperature and then mean January temperature, that is about 18 degrees centigrade. This area cold is very less, and then frost is almost absent, very luxuriant vegetation you will find here. Then subtropical, where the temperature is this much, 17 to 24 degrees centigrade, and then mean January temperature is 10 to 18 degrees centigrade. Here winter cold season is there, but not very severe. So we have a very good forest, and distribution of the trees are as per the Silvics here. Then temperate, where we have 7 to 17 degrees centigrade, and mean January is minus 1 degree centigrade to 10 degrees centigrade. Here we have what? Winter is pronounced, frost is there, snow is there. Then alpine zones, very high. There we have mean January temperature under minus 1 degree centigrade. Winter is very long, and then growing period is very, very less. Much of the snow is there. So the trees or forest is divided under this temperature in broadly 4 categories. So in this lecture we have studied about forest, forestry, silvics, silviculture, and that is very important. To do silviculture we need locality factor, habitat factor, site factor. Under that we have 4 factors we have studied, and this which is classified under 4 categories called climatic, topographic or physiographic, edaphic, biotic. Under that one, in this lecture we studied about climatic, and on climatic we studied solar radiation, and the solar radiation we have just gone through light and temperature. So in my coming next lecture we'll continue on the locality factor. Keep watching the series of lecture under silviculture. Thank you.